This video is brought to you by Altium 365, where the world designs electronics, and Octopart, the fastest search engine for electronic parts.
Get a free copy of Altium software using the link provided in this video description. Plus, when you sign up for an Altium Designer free trial, you will get Altium 365 and 25% off discount. Hi guys, so today I'm gonna show you on how to create LM2576 Buck Converter using Altium Designer. So here's the schematic. Here's what we're gonna do. Here's the output and here's the PCB. So let's get started. So first, you should have a project file. So this is the created project file. In order to create a project file, just click on File, New, then Project. Then this is where you can set the project name and the file location in where you want to save the file. So next thing we need to do is to create a library. So these are the components that we needed, and we're going to create each one of these in the Altium. In order to create a library, just click File, New, Library, then Schematic Library. So let's start creating the library. Let's start first with the capacitor. So let's place a pin. So click Place, then Pin, add a pin here, rotate it, and add another pin. Let's put this on the side first. So let's change the designator of this pin into 1, then the pin name into 1 also. Then the next pin will be pin 2. Just input here in the properties panel. Let's hide first the pin name. Then let's rotate this one. Next thing is to create the body of the capacitor. So click Place, then Line. Then to access the properties, just click Tab on your keyboard. Then change the line to whatever you want. For this case, small. Then the line style for solid. Then let's just copy this one and paste it on the other side. And drag this one. Since we're creating a polarized capacitor, let's put a positive symbol here. You need to input also the properties of the component. So for design item ID, let's put 200 microfarad here. Then C for the standard designator of capacitor, and let's just copy the design item ID into comment and description. In order to add parameter, just click the add here. Then we need also to put the manufacturer and manufacturer part number. Then input the name, manufacturer part number, then manufacturer. So the value is based on the list earlier. So let's just copy the manufacturer and manufacturer part number here, provided by Rubicon. So there you have it. We're done creating the capacitor. Now let's move on to another component. To add another component, just click this Add button under the Schematic Library panel. Then we can put here the design item ID for the new component. So next component will be 1K ohms resistor. Just click OK. Next component will be 150 microhenry. So let's add a pin here. Then change the designator and name the pin 1. Then for creating an arc, just click place, then arc. Pick anywhere. There. Then as you double click the object, we can change also the parameters or the properties of the object. You can also drag this one so you can adjust the arc. Then you can just copy this one and paste it so you can create a simultaneous arc. There you have it. For the next component is LM2576 IC. So for this one, I'm gonna show you on how to edit the pin properties or the pin type. So just click the pin, then you can input here in the name the pin properties of pin 1. Then for the electrical type, you can change it here. Pin 2, output for the name and electrical type output. Then for pin 3, power, electrical type and the name is ground. 4, passive feedback. Then 5, passive on or off. All the components. Here you can see the looks of all the components created. So for 1K, for the diode, 2-pin header, 10K resistor, 150 microhenry, 200 microfarad, and the IC LM2576. Since we're finished with the schematic library, next thing we need to do is the footprint or the PCB library. So to create a PCB library, just click File, New, Library, then PCB library. After that, this is the open space where you can create the objects for your footprint. Then you need to place a pad. So make sure that if your component is an SMD or SMT, it should be placed on the top layer or the bottom layer. So I'm gonna create the footprint of the inductor. So the footprint, the dimensions will be based on the datasheet, based on the manufacturer you choose, and the manufacturer part number. Then you can edit again the properties of the pad here at the properties panel in the shape. So for this case, 114 mils and 213 mils is the recommended pad based on the datasheet. So just press space on your keyboard to rotate. Then for the designator, we can put here 1. It should match the pin designator you assigned on the schematic library. So just place it here for the meantime. Then it will automatically add another pad. Then just place it here. You can also change the location here based on the datasheet. After you finish placing all the paths for the PCB footprint, next is we're going to add a top overlay. This will be seen on the actual board as your silk screen. So make sure that the active layer is on top overlay. So before the active layer is on top layer, just click on top overlay to activate this layer. Then we can add the top silk screen here. So just place line. Then you just can copy this one. Then click for the origin. Then Ctrl V, paste. Then just press Y to rotate it vertically. Then click again for the origin. Now that we have a pad and a silk screen for this component, next thing we're gonna do is to add the 3D body. So for this component, I have already added the 3D body, which is placed on mechanical layer 1. So I'm gonna show you on how to add the 3D body. So the 3D body will be available on the internet. Just search the package of the particular component. To add the 3D body, just click place, then 3D body. There you have the open dialog box in where you can choose the downloaded 3D body available on the internet. Just click the STP file and then click open. Then it will automatically add on your PCB library. So to check on the 3D body, just press 3 on your keyboard. So there you have the 3D body on your library. Next, we're going to link the PCB library into the schematic library. In order to do that, just go to the project panel, then click on your schematic library, then find the inductor. So this one, double click this one to access the properties, then add footprint here. Just click add, or you can also click this one at the bottom area. So click add footprint, then type inductor. So it will automatically find the created PCB library. So just click OK. Now repeat the process in linking the PCB library into your all schematic library. So next thing we're gonna do is to create a schematic. To create a schematic, just click File, New, then Schematic. So now this is the sheet template where you can add your components. We can also adjust the sheet template according to what you like by clicking this custom on the properties panel, and we can say let's put here vertical 2 and horizontal 2. Then for the width, let's say 200 mm. Then for the height, 150 mm. So I shrink the sheet template since we have a small schematic. Now to add the libraries, just click on the panel, then click Components. So it will appear all your schematic library you created. So to place it on the schematic sheet, just double click the component. Then click on the sheet. Then click right click to cancel the command. So do this in all library. Just double click. After you place the components in the schematic sheet, next thing we're gonna do is to add the wires for the connection. Just click place, then wire. Just click on the end pin of other components to where it connects. So the connection will be based on the required schematic. Next, we're going to add the power port for the connection of ground. To add the power port, please click Place, then Power Port. Then press Tab on your keyboard to access its properties. So for this case, we'll be needing the ground for the net. Then we can choose the style. So for this one, power ground. So let's put here for the meantime. And we can connect it here directly. Now we're done with the schematic. Next, we're going to create a PCB. Just click on File, New, then PCB. It will open a blank PCB. So just save the project PCB file, then save also the PCB document. So next, go back to your schematic doc and click on Design, Update PCB document. Now the engineering change order dialog box will appear. So these are the components that we'll add on your PCB, and the nets as well, and the component classes and the role. So just click on Execute Changes. So now you can see these are the components added on the PCB. Next, we're going to create the shape of the PCB. So to create the shape of the PCB, just draw a rectangle by placing a line. So click Place, then Line. Now enclose the line to create the shape. Then click the shape. Then click on the Design, Board Shape, Define from Selected Objects. So this will be the size of our PCB. Then now we can start placing the component. So just hold and drag the components to place it according to what you like. After you finalize the component placement, now we can start with the routings. You can see we have a line here. These are the rat nets. So this is the guide on where the pins or the holes is connected. So to route the board, just click on Route, then Interactive Routing. So just click. Then click again to complete its connection. Now for the connection of ground, we can turn this full PCB into a plane. So to convert this all in a plane, just click the board outline, the line you created a while ago, then click on Tools, Convert, then create polygon from selected primitives. Then to adjust the properties of the polygon, just double click the polygon, just make sure that on your selection filter the polygon is selected. So the net will be ground. Then click on apply. We can also adjust the fill mode to solid. So click apply again. Then to see the changes, just click on Tools, Polygon Pores, and Repore All. Now you can see the whole PCB turns into a plane, and there's a relief connection to the ground. So to view the 3D of the board, just press 3 on your keyboard. Now we're done with the layout. Now that's all in designing the LM2576 Buck Converter. Thank you for watching.